Hi friends, once again welcome back in our educational channel, that is Milinda's Ideas. Friends, in previous lecture we had studied multiplexer ICs and we had studied the IC 74153 because it is a part of our syllabus. That IC 74153 is dual 4:1 marks. In that IC, there are 4 inputs, so 2 control lines are required. There is one output terminus, and to make the particular mux enable, there are 2 strobe input or 2 enable inputs. In this lecture, we are going to study multiplexing tree. It is a multiplexing tree. First of all, what is the necessity of multiplexing tree? IC 74150 is the largest available mux in IC form. This IC has 16 input and 1 output. So it is basically 16:1 mux. The output of this IC is an inverted input. It has a 16 input, 1 output, and to select the one of the input out of that 16 input, the 4 control lines are required. But it is a 16:1 mux. So if there are more than 16 inputs, this IC is unable to select the input data. So for that purpose, to meet the larger input, to convert the larger inputs, we have to use a multiplexer tree, multiplexing tree. So in that multiplexing tree, we can able to connect more input into single outputs. And in this video lecture, we are going to study how the multiplexing tree is achieved. We are going to study 8:1 multiplexer by using 4:1 mux. So basically it is a 4:1 mux, but this 4:1 mux is converted to connect 8 inputs to output terminal. So 4:1 mux is converted to 8:1 mux. So friends, in front of you, the multiplexing tree, the circuit diagram or logic diagram of multiplexing tree is going to be displayed. Basically it is a 4:1 mux. So as there are 4:1 mux, there are 4 inputs, that is I0 to I3. As there are 4 input, there should be 2 control lines or 2 select lines. So S0 and S1 are the control lines. As this 4:1 mux is converted to 8:1 mux, so now there are 8 inputs. So obviously there should be 3 control lines. So how the third control line is achieved? When 2 mux are connected, we are going to select one of the mux, and for that purpose there is a provision that is known as a strobe or that is known as an enable. So in this case, the strobe input is connected as a control input. The third input, that is a S2, is connected to the strobe input. How it is connected to the strobe input of particular mux? As there are 2 mux, the lower mux is considered as M1, the upper mux is considered as M2. That strobe input is connected to strobe input, or that is a control input S2, is connected to the strobe input of lower mux through NOT gate. So the strobe input is now complement of S2. Strobe input for lower mux is now complement of input, while the strobe input is directly connected, that is a control input S2 is directly connected to the strobe input terminal of upper mux. As there are 8 input lines, that is I0 to I7. The I0 to I3 inputs are connected to the lower mux, that is a D0 to D3 inputs, that is the data inputs. D0 to D3 input data inputs are connected to the input terminal of lower mux, that is I0 to I3, while the data inputs D4 to D7 are connected to the input terminals I0 to I3 of the upper mux, that is a M2. So now we have 8 inputs, that is a D0 to D7, D0 to D3, that 4 inputs are connected to the lower mux, and D4 to D7, that data inputs are connected to the upper mux. The output of this mux, that is Y1 and Y2, are connected to OR gate, which gives a single output, because output of OR is addition of input. So output of this circuit is y1 plus y2. When one of the input is high, that is y1 or y2, the output of this gate becomes high because it is a OR gate. Now how this multiplexer works? As the control inputs S0, S1 and S2 is common to both that mux. When the strobe input is low, the mux is in disable mode, and when the strobe input becomes high, the mux is in enable mode. So up to 4 actually it is that is 0 0 0 1 1 0 and 1 1, that is 3, but it is a 4 inputs. So up to 4 control inputs, the lower mux is in enable mode. How is it possible? Because up to 1 1 the control inputs are 0 0 0 0 0 1 0 1 0 and last is 0 1 1, and after that the input changes to control input changes to 1, that is S2 now becomes 1, S1 becomes 0, S0 becomes 0. but below this मी याच्या खाली जर आपण बघितलं मी केव्हा कुठपर्यंत up to 0 1 1 the lower mux, that is M1, is in enable mode. Why it is enable mode? Because the strobe input of this mux becomes high, because that low input connected to the S2 terminus is converted to high input by using the NOT gate, by using the inverter. So up to 0 1 1 the lower mux, that is M1, is in enable mode, and the data connected to that mux, that is M1, that is from D0 to D3, is selected as per the input signal, that is a S1 and S0. But after 0 1 1 the control inputs now become 1 0 0, the next 1 0 1, next 1 1 0, and last one is a 1 1 1. So as this control input S2 is high, the strobe input of lower mux goes to low level because it is connected through NOT gate. So output of NOT gate now becomes low. But as the control input S2 is high, the upper mux is in enable mode because its strobe input is high. So now as per the remaining control inputs, that is 1 0 0 1 0 1 1 1 0 1 1 1. So as per the remaining control inputs, the data connected to I0 to I4 of upper mux, that is M2, that is basically data inputs D4 to D7, is selected and connected to the output terminal of that mux. That means in this case the output Y1 is equal to either D4, D5, D6 or D7, and that data is connected to OR gate and it is connected to the output. It is connected to the output terminal through this OR gate. So this strobe input, that is a S2, in this case it is a S2, that decide which mux is in enable mode, and the remaining control input decides the data connected to that input terminus is selected, which data is selected and fed to the output terminus. Now we are going towards an example. For example, if the control inputs are 0 1 0, it is 0 1 0, as S2 is 0, the lower mux, that is M1, is in enable mode. And as the remaining control input, that is 1 0 I2, the data connected to the I2 is selected and fed to the output terminal of mux. Now data connected to the I2 of the lower mux, and that is D2. So in this case, from D0 to D7 the data, that is D2, is selected and fed to the output terminal. But if the control inputs are 1 1 0, it is 1 1 0, as S2 is 1, that means strobe input is high, the lower mux is in disable mode while the upper mux is in enable mode, and as per the control input, remaining control input, that is 1 0, once again the I2, the data connected to the I2 is selected and fed to the output terminal. But friends, in this case the data connected to the upper mux, the I2 terminal of upper mux, is selected and fed to the output terminal. So in this case that data, that is D6, is selected. So from D0 to D7 the data D6 is now selected and fed to the output terminals. So that is multiplexer, that is multiplexing tree. So by using the strobe input we can convert the multiplexers into, we can convert the multiplexer to meet the more inputs. In this case, we convert the 4:1 mux into 8:1 mux. Similarly, 8:1 can be converted to 16:1. 16:1 can be converted to 32:1. So friends, that is multiplexer tree. That is a multiplexing tree. Now, what are the advantages of this multiplexing tree? First of all, it minimizes the IC required. In this case, it is a 4:1 mux. So IC 74153, a single IC, can be used to connect 8 inputs to single output. So the number of IC required can be minimized. Second, simplification of circuit is very simple. मैं आपण सर्किट से सिंपल करतो, मैं इजी आपल्याला करायचं असेल by using Boolean laws, Boolean algebra, the simplification of this circuit can be easy. The simplification is not required. Actually, it is not required because it is a very simple circuit. The next point is designing of circuit becomes very simple. Circuit designing, how that 4:1 is converted to 8:1, 8:1 to 16:1, 16:1 to 32:1, etc. etc. The designing of circuit is very simple. First, we have studied that is a minimum. It minimizes the number of IC required. The second, the simplification is not required because the circuit already makes the simples. Next, the designing of circuit is very easy. Next, as the single IC is required, the number of ICs are minimized. The cost of this circuit, cost of this multiplexer is reduced. The cost become less. So these are the advantages of multiplexer. That is a multiplexing tree and the multiplexer. So next, the application of multiplexer. The multiplexing circuits, where these multiplexing circuits are used, they are used in a different digital circuits such as data selector. Multiplexer is also known as data selector. In first lecture we had studied that multiplexer also known as a data selector. Demultiplexer is data distributor. So multiplexer is a data selector. It is going to select the data, so it is used as a data selector. It is used in data routine operation. It is also used in waveform generation. It is also used in logic function generators. And these multiplexers are also used in communication fields. So friends, that is multiplexer. In next video lecture, we are going to study demultiplexer, that is data distributor. So friends, once again, thanks for watching this video lecture. Thanks for subscribing our YouTube channel. तुम्ही फेसबुक पेज फॉलो केलं असेलच, फेसबुक पेजला फॉलो करून ठेवा. द सेम, दॅट इज मिलिंदाज आयडियाज नावाचं फेसबुक पेज आहे, त्याला फॉलो करून ठेवा. सो फ्रेंड्स, इन नेक्स्ट लेक्चर वी आर गोइंग टू स्टडी द demultiplexer. So friends, once again, thanks. Bye. Take care. See you again.